Hello everybody. This lesson is going to pick up where I had last left off, where I'd given you the practice exercise called Drafting Fundamentals to work on. And that was a front and backside assignment. And what I'm going to be doing first today is reviewing the answer key for that assignment. So I'm going to be clicking here and we're going to be taking a look at the results. So here is page 1. So if what you're seeing here looks the same as what I have on your sheet, then you can give yourself a pat on the back because you've done things correctly. So we're taking a look at the block. We're seeing always in the bottom left-hand corner the front view, which shows this surface and this surface. Directly above, with one grid space left between views, we see the profile of the top view. And then one grid space between the front view and the right side view, we see this surface and this surface for our right side view. And the same thing goes for the slider. Now, the slider will show you the hidden detail line. That is one square up from the bottom, and that would exist right here where my cursor is, because the inside of that slider is a slot, and the depth of that slot needs to be represented by a hidden detail line here. And we have the tongue, and the tongue is very similar to the step guide, except the step guide also has a hidden detail line on the top view here, right? Because this is, the bottom is 3 grid spaces to the right, and above we see our hidden line right here. And now we're going to take a look at the back. So the back side of this sheet, we've looked at the riser piece and the machine key. Now here, much like we've seen in the PowerPoint presentation, this is unfolding the glass box, right? So the object is sitting inside the glass box. The glass box is cut and unhinged in such a way that opens up a two-dimensional viewing for all 6 sides, right? As seen in this order. So we have our typical top, front, and right side view here as always, and we're introducing the bottom, the left side, and the rear with this exercise. So the front view is looking at this in this direction where I'm pointing with my cursor here. So that's what that looks like here, right? We see this surface here that is totally running vertically, perfectly straight up and down, and then we also see this surface here which is on an angle, right? When we look at this dead on from the front view, we have no perspective that this is on an angle. But when you look at it from the right side view, which is right next to it, we're going to see this surface here and this surface here. Basically, it looks just like a block with a diagonal line struck through it from bottom left to top right. And when we look at this from the left side view, it's the exact same thing, except it's flipped the opposite way. This diagonal line must travel the opposite way, and this line becomes a hidden line, because when we look at this from the left side, we have no perspective of being able to see this angular cut here, right? But we know it's there. We still have to show it with a hidden line, right? The top view is basically identical to the way the front view looks. Looking at it from above, it's going to look exactly the same as we see on the front view. The bottom view looks from underneath. It's going to look just like the top view, except from the bottom we can't see this cutaway on an angle, so we're representing that line with a hidden line. And basically the rear is the same thing. We're looking at this from the back side, and again we have to represent that angular cut with a hidden line. So there's our basic 6 sides for our 6 views. Looking at the machine key again is very similar. It is the same 6-side layout that we see here as in above, but the origin for this piece is right here where this curves, right? So this is 2.5 grid spaces here, as you can see, and that's what I've done here with the front view. I've done 2.5. The origin is actually sitting in a half square, right? So the vertical part of the origin is sitting right in the middle of that grid space right there. So this represents 2.5 spaces, and then the key part here is 2 full spaces. Looking at this from the right side, we're going to see a 3 by 3 square. So we're looking at this surface, and we're also looking at a solid 2 grid step vertical line here, 1 and 2. Looking at this from the left side, again, it's the opposite of the right side, just like above on the riser piece. This is going to be appearing as a hidden line because we cannot normally see that from the left. The rear is basically just a simple flip of the front view. It looks just like the front view, except it's pointing the other way. And then the top view gives us the perspective of the radius, right? So again, this is 2.5 squares. We can easily see this surface and this surface. And then looking at it from the bottom, it looks the same, except there's a very subtle difference between the bottom and the top view. This vertical line that exists between this horizontal line and this horizontal line is still here, except it's shown as a 2- hidden line, right? It's very short, it's very small, but this we have no way to see or to know that this steps down here, that this isn't flush with the top surface, right? When we look at it from the bottom. So basically we have to show, the only way we can represent that is with a hidden line here. And that's basically it, right? We only have that hidden line and we have these hidden lines here for that one. So that is how you should lay out your 6 standard views orthographic projection for the backside. So this worksheet is not going to be marked. This is for your understanding. Now, we're going to talk about the assignment next, but I don't want you to move on to that assignment if you're not understanding this concept, right? So I really want you to keep studying this concept. If you don't understand it, I want you to redo this practice sheet. Understand the views. Remember, there's an arrow pointing in this direction for the front view. There's an arrow pointing in this direction for the front view. You can't see it on the sheet, but I'm telling you, and that's how we find out where to start with our origin and then build all the other views around it from there. Keeping in mind, we're always leaving 1 grid space between views. In these 2 examples and these 4 examples from above. Alright, so moving on, we're going to take a look at orthographic sketching problems. And we're going to talk about this assignment. So I'm going to read over this. So it says, complete a 3-view orthographic projection of the following isometric blocks, 2 to 24 only. And we're going to discuss what I mean by 2 to 24 in a moment. It says, skip all of the odd numbers, use the grid paper supplied to you, and make sure your pencil is always sharp. Use a ruler to keep your line work straight and neat. Number all problems and leave 1 grid space between views. And don't forget to add hidden detail lines where required. remember to use the proper format for basic 3-view orthographic projection. The front view is always identified on the sheet with an arrow and will be placed in the bottom left-hand corner for each problem. You are encouraged to use a drafter's circle template to assist you in the drawing of your radii and circles as required at the end of the assignment. Note, watch the scale of the grid spaces as not all of them count as a whole. When completed, write your name on the assignment and submit to teacher for marking. Okay, so let's take a look at the assignment. So this is it, blocks 1 to 24. So there's 24 of these problems shown here, right? And they're all in isometric view. So your job in this assignment is to start at number 2, right? So you're skipping number 1. You're going to be completing the basic 3 views for orthographic projection, top, front, right side. And you're going to be skipping all of the odd number problems and just doing the even numbers. So you're doing 2, 4, 6, 8, 10, 12, and so on, and you're going to be finishing at 24. Now, what we have to understand is there's always an arrow that's pointing to the surface that is the front view. So item number 1 actually has it labeled. It says front, and 13 has it labeled front, even though you're not doing number 1 or number 13 in this assignment. But for number 2, we have the arrow pointing. So we know where our front view is at all times because the arrow identifies it. So if we know where the front view is, we must be able to know where the top view is and the right side view. So when we look at number 2, and I've done number 2 for you, so I'm going to be showing it to you in a moment. The arrow points to the surfaces that are on the front view. So that's these surfaces and these surfaces. We're going to leave 1 grid space, and then we're going to draw the top view above, and we're going to leave 1 grid space, and we're going to be drawing the right side view to the right. Now, just because you can't see the right side view in number 2 doesn't mean you're going to default to drawing the left side view, right? Just because you can't see the right side view doesn't mean that you can't interpret what it's going to look like. Remember, it's not top front left, it's top front right, right? I have this one completed for you. I'm going to show it to you. The same goes for number 4. We can see the front view, we can see the top view, we can clearly see the left view, but we don't need to draw the left view. We're going to be drawing the right side view. We can't see it. It's not in our line of sight in isometric view here, but we should be able to interpret what it looks like. And by the way, I haven't done all of number 4 for you. I've just started it, and you're going to have to complete it on your own. And that text that I just read to you, it talked about how not all of these count as 1 full grid space. So as we look through here, I would say number 2, they all count, they're all holes. Number 4, they all count, I can count even grid spaces. Number 6, I would agree with that. Number 8, I would. Number 10, I would. Number 12, I would. So a lot of these are even, right? 14, yes. The same with 16. I would say the same with 18. But when we get to number 20, and this is the second last one. Sorry, it's the third last one because you're going to do 20, 22, and 24. This one here has some phantom grid spaces in front of it, right? So you're not going to be drawing these phantom grid spaces that are sticking to the front view, but this is to help show you that this flange on the left and this flange on the right are not symmetrical, right? So this one is coming over about, it looks to me like this horizontal line about a square and 3/4, and here it's coming over about, roughly a square and a half. So that's something that you have to pay attention to as you're doing this, right? Is it full grid spaces or is it not? Most of them are. That's very, to me, that might not be so clear for a student to understand, so that's why I'm discussing it right now for you. And it's very difficult when you're working at home to complete arcs, and radiuses free-handed. So, do your best. Really take your time to try to draw these things, as perfectly as you can. You don't really have a drafter's circle template at home, I'm going to assume. So just try your best and just try to draw these things as neatly as possible. Okay, let's go back and let's take a look at the rubric for this assignment. All right, so this is going to be in Curriculum Strand A, Overall Expectation, which is representing design ideas graphically. So let's take a look at, level 0 through level 4, and we'll discuss how the mark will be generated. So it says for level 0, drawings are not in orthographic projection, and they are missing one or more of the required views. So if you're only drawing one view or two views of each of the problems out of 3, and they're not in those two, or one, that if those two views are not in orthographic projection, you're basically scoring level 0, right? Which is not a pass. Now level 1, let's discuss that one. It says drawings are not in correct orthographic projection, meaning the top, front, and right side views are completed, but are not placed in any definite relation to one another. So what that means is you've created the 3 views, they've been created correctly, but they're just placed on the sheet of paper in an area wherever the heck you've decided to put them, right? So if they're not lined up correctly, that is not a thorough understanding of this assignment, because we've always discussed, and even in working with Autodesk Inventor, that the views have to be lined up to one another, right, in a certain specific order, which we've discussed and we've done in the practice exercise I've just talked about. Level 2, drawings are in orthographic projection, but some features of the views are not aligned properly or are in the correct projection plane. So, meaning that could mean that you've drawn a left side view instead of a right side view. That may mean that you've actually drawn a view pointing the opposite way, and the view might be slightly out of alignment with another view. So those are examples of what a level 2 mark would look like. Level 3, drawings are in complete and correct orthographic projection, and some of the object and/or hidden lines are missing or are not shown appropriately. So again, if you're missing hidden lines, if you're missing some object lines, there's some features of the views that are left incomplete, that's going to get you into level 3. Now let's talk about level 4, 80 to 100. Drawing is in complete and correct orthographic projection and includes all of the object lines and hidden lines where they are shown appropriately, and a ruler was used to keep line work neat. So if you're going for a really high mark on this assignment, which of course you should be, I'd be using a ruler with your pencil and making sure that you're drawing these things with clean, crisp, straight lines. Now, there is a variance here, so we can allow a couple of mistakes on each problem, and it would still keep you in level 4 if you forgot one hidden line or 2 hidden lines by accident. That would still get you into level 4. But if you miss multiple lines, right, you're dropping down into level 3. Now this is out of 10, which doesn't seem like a lot of marks. But remember, it's not about what it's out of; it's about what the assignment is weighted in my gradebook calculation, right? So what we're going to do is, because we have 12 problems that you're going to be creating an orthographic projection manually with a pencil, what I'm going to be doing is I'm going to be assigning every problem a level. It could be, one problem could be a level 4 mark, I give it. Another one could be a level 3. Another one could be a level 2. Right? So each problem is going to get their own level assigned to it. And what I'm going to do is I'm going to take the average of all those problems based on the mark it receives in a level. And that's how I'm going to generate the mark out of 10. Let's go back. All right, so let's take a look at my example. So this is something that I have created. I've started the assignment for you. So you can, on your sheet of paper, you can copy what I've done so far because it's correct, but you're going to have to complete all the rest of them. So I haven't done very much here. I'm just going to rotate this clockwise so we can see it more clearly. All right, so this is what the first one looks like. Now, I've made an error here, and not with the views. I haven't made an error drawing the views. I labeled this as number 1. And what I should have done is label this as number 2. Right? Because this is the second problem. We're skipping number 1. So in an effort not to confuse anybody, this should say number 2, just like I've done here. I've labeled this one correctly as number 4. So I have the top view, the front view, and the right side view completed. The right side view includes a hidden detail line here. So a little dash line, because when I look at this from the left side, that's how I'm identifying this top prism structure here, right? Because it sits back into the top right-hand corner, and that where this height is different. The height of this surface is different from the height of this bottom base piece. So that has to be identified with a hidden line. And number 4, I've done the top view for you. And then you're going to have to come up with the front view and the right side view, which is going to go here. Right? So this top view is fully complete. And it includes one hidden detail line running horizontally here, which I'm sure you can understand why it's there. Now, let's talk about a common mistake that can be made by students when doing this assignment. And this is something I've noticed in the past with other students in other classes. So a student may start drawing with the front view first, which is okay. So what they do is they would typically draw the front view where I have my top view at the top of the sheet. And then they know, okay, I'm supposed to put the top view above the front view, but they don't have any room for it up here now because they don't have enough paper. So what they do is they draw the top view below the front view, and they basically just draw an arrow, and they say, should be up here, but, they don't have enough room, so they feel that drawing an arrow and then labeling it like that would make it correct. And it doesn't make it correct. So if you're looking for full marks, you have to do this correctly, and you have to actually draw the 3 views in the correct relation they're supposed to be. And this is the way I'm doing it as per the lessons and everything that you've been shown so far in the PowerPoint, in any example I've shown you in Autodesk Inventor, and so on. So top view must be on the top always. Front view must be below it. Right side view must be to the right of the front view. Now, the grid paper used, the grid paper I'm using is a 1/4 inch square. So basically every grid space you see on this sheet of paper measures 1/4 by 1/4. Now, it doesn't have to be 1/4 by 1/4 grid paper. If that's what you have at home kicking around, then that's perfect. You can use that if you have some at your house. If you don't have any grid paper at your house, you could go to the store and you could buy some. If you don't feel like going to the store and buying some, you can do this. And I've uploaded a blank piece here. And this is something that you can print off on your printer at home. Right? We just rotate this. And this should be acceptable for you to use. Now, if you don't have any, if you don't have a printer, I'm going to highly recommend that you go out and buy a little bit of grid paper at your local supply store, right? And when it comes time to hand this assignment in, so this assignment is going to be handed in hard copy. So when you come into school for your face-to-face learning block, you're going to be bringing it to school with you. You're going to be handing it in hard copy to me in the classroom. Those people who are on remote or are going to be staying remote in block 3, they can scan the assignment and then do an electronic hand-in to the assignment folder in the hub. And this assignment is going to be counted as a part of your midterm grade calculation that's going to be coming up shortly. So that concludes my lesson, my review on the answer key, found here in my introduction to the orthographic projection assignment, paper and pencil and ruler assignment. Should be pretty straightforward. And we've seen all this in Inventor already. So I'm basically going to end this video now. And if you're having any difficulty with this or understanding these concepts, remember that I'm available for help. Get in touch with me in class time, and I will be happy to give you a hand and get you up to speed. So, take care for now, and good luck with this assignment, and I will talk to you soon. Take care.